Hi, sweeties. I hope you have had a good break. The second half of the year is very, very, very important for us. We are wrapping up the rest of the units and we are going to start EOC review. If you don't have a calculator by now, please get a calculator, a scientific one. It's $13 at Walmart, or a graphing one. It's a little more expensive, but you can use it later on too. So we're going to talk about the next unit, which is on chords and secants. Any of the old material that you haven't mastered yet, or at least become proficient in, please go back and rewatch those videos and redo those problems. At this point, I need you to be doing as much as you possibly can to learn, and read as much as you possibly can so we can build up your reading comprehension so that you can be successful on the geometry EOC. Okay, so now we're going to talk about chords and secants in a circle. The standard that we're going to cover is to identify and describe relationships among inscribed angles, radius, chords, tangents, and secants. In this lesson, we're going to focus on finding the missing portions of a chord in a circle, and how do we find the missing portions of a secant passing through a circle. So our key vocab is a chord and a secant. Let me go back and show you what a chord is, and then I'll draw it again. A chord is when you have a line segment that touches the circumference of the circle and stop. So this red line is called a chord. And then I can have another chord is when a line touches the circumference, which is the blue part. This is called the circumference of a circle, which is the outside edge. And the chord, it touches the circumference in two spots and stop. So it intersects the circumference. There are some rules when these chords intersect, and we'll talk about that in just a second. I'm going to draw another circle, which is here, and we're going to talk about the secant. So the purple is the circumference. A secant is when we have a line that intersects with the circle, but if you notice here, it doesn't stop. It intersects here at point A and point B. And sometimes these are labeled and sometimes they aren't. But the key is the secant keeps going on forever. So it intersects with the circumference of the circle and it goes on forever. So that's another example of a secant, this red line. The ones that you are going to see the most common is when your secant, so let me draw this secant like this. So here this red line is a secant. It touches the circle twice and it intercepts the other secant. I'm going to show you one more way in which you can see a secant. The red is the circumference of the circle. And here you can see the secants. Those two purple lines are called secants, and they intersect here outside the circle, but they touch the circle here and here. And let me draw the other. And they touch the circle here and here. That's a secant. Those purple lines are called secants. They touch the circle and don't stop. They extend on both sides. Okay, so now we're going to talk about how do we find the missing segments of a chord. How do we calculate it? So I'm going to draw my green circle and I'm going to put a chord. I'm going to put here and here. I'm going to call this A. I'm going to call this B. Then I'm going to draw another chord. I'm going to call this C, and call this D. And the point of intersection right here, we'll make that black. We'll call it F. Okay? And I'm going to call AF B. I mean, not B, but I'm going to call it E. EF G. FB H. And FD I. And I think I said, well, this is FC right here. So if I wanted to find any missing segment, so the rule tells me that line segment AB is broken up into two parts, EF and FB, or I call them E and H. So E times H would equal, and then I go to the red line, which is DC. DC is made up of two parts, DF, FC, or you can call them I and G for simplicity. So I times G. That's what the rule tells you that these equal. And the way that I remember, the orange and the red line makes an X. And that stands for multiplication. That's the symbol for multiplication. So you break the pieces up, multiply them, and set them equal to each other. Alright, now I'm going to draw another circle. The black is the circumference. I'm going to draw one secant. And I'm going to call this point where it intersects the circle as A. Where it intersects the circle here as B. Then I'm going to draw another secant. And where it intersects the circle, I'm going to call C. And where it intersects the circle here, I'm going to call D. And where they intersect outside the circle, I'm going to call E. Okay, so the rule for this, if you look at the blue line, which is this secant line, this line has two parts. It has an outside part, and it has the whole part. Okay? Now I'm going to do the same for the other line. It has the outside part, that's blue. And then I'm going to do in purple, it has the whole part. Alright, so I'm going to label these parts. I'm going to call the outside part K. And I'm going to call this part inside of the circle J from A to B. And then I'm going to call parts from D to C I. And the outside part E to C as P. So the rule here tells you to do outside multiplied by the whole. And that should equal the outside multiplied by the whole of the other side. Let me move this over. So you get outside multiplied by the whole should equal outside multiplied by the whole. And for short, I just like to write it OW equals OW. Okay, so I'm going to do the first secant to show you how this will get set up. So I'm going to do the blue secant first. The outside that I highlighted is K. So I'm going to do K multiplied by the whole, which is from A to E. So I'm going to do multiplied by JK. And that should equal, now I'm going to do the second one, the outside, which is P, multiplied, oops, not JK, but J plus K. Sorry guys, J plus K makes up that secant there. And then here I do the outside multiplied by the I plus P, the whole. I plus P makes up the whole. Now that's the general terms. I'm going to show you some examples so you can see what I'm talking about more. Alright, so let's try this one together. I have two chords here. And since I see that these are two chords, this is a chord, and I'll highlight those chords. That chord, the green chord, and the yellow chord. These are the two chords that I see. And it's asking me to solve for X, and this looks like multiplication, how those lines cross. So I know I'm going to multiply the two parts of the chord. So I'm going to multiply the two pieces of the green chord, which is going to be X plus 5 multiplied by 6 should equal, and I'm going to multiply the two parts of the yellow chord. So that's 7 times X plus 3. Or you can put X plus 3 times 7. Multiplication is commutative. Alrighty. So here I'm going to do 6x plus 30. This is distributive property equals 7x plus 21. Now, for those of you that are still trying to master your solving equation skills, here's a way that you can look at this. I'm going to draw a dotted line down the middle of this, and if I cross over the line, then I change the sign. The object here is to get the variables on the left side of the line and the constants on the right side of the line. So I'm going to start with my constant first. So if this is a plus 30 and I want to go put it over here with this constant, which is 21, then I'm going to minus 30 because I'm crossing over that line. If I cross over the line, I have to change the sign, and that should be 30, not 31. Okay, I bring down the 6x, should equal 7x, and then you do 30 minus 21 minus 30, which is minus 9. And you can always check yourself with your calculator. Now, I want to put all the variables on the left side. So if this is plus 7x, I want to get this 7x on the left side. So I'm going to subtract 7x because I have to cross over the line. And here we get negative 1x equals negative 9. So I'm done with switching stuff across the lines. Now I need to undo multiplication here, which is to divide by the number in front of x. So I'm going to divide by negative 1. So here, x equals 9. And we found it. So to check yourself, you can always go substitute back in and see what the math would be if you go and put in 9 up here. You should be able to say 9 plus 5 times 6 should equal 7 times 9 plus 3. And if these two sides equal, then you got the answer correct. So let me give you the rule here with solving this equation. If you cross over the line, you want the variables on left. If you already know away from Algebra 1, then stick with what you know. But for those of you that are trying to learn it, variables on the left, constants on the right. And then if you cross over that line that you draw down the middle, then you change the sign. That is a way that you can solve these equations. All right, so here's what I need you to do. Go through, complete this one, this one, this one, and this one. And then we'll get to come and do this one with me. So here, what I noticed with this problem is this is two secants now. And if you extend this, you notice that it extends on both sides. If you want to extend this, that's a line that can be extended on both sides. Chords stop, secants go on. Touch the circle twice and go on. I touch the circumference twice and they go on in this case. So, well, in all cases with secants. This was my point of intersection right here. So what I want to identify is the outside. I'm going to do this first one, first secant first. So here, this is my outside. And my rule tells me to do outside times the whole, outside times the whole. So here, my outside is 7 for that first one. So I'm going to do 7 times, and then I need to go get what the whole is. So if I go look here, the whole, I'm going to highlight in red, is 7 plus 17. So 7 plus 17 is the whole. And that should equal, now if I go to the second secant down here at the bottom, right here is the outside. Let me change that. Right here is the outside. So the outside for that is 8. And now we need to go get what the whole is. So let me go and highlight the whole, which is in blue. And that is going to be, that whole piece of that secant would be 8 plus x. Alright, so you get 8 plus x. And here, you do the math. So, I'm back to the solving an equation. If you cross over the line, you change the sign. So that's my dotted line down the middle. And here on this side, you can use distributive property, or you can use order of operations on the left side. I'm going to use order of operations. So I get 7 plus 17 is 24. And that should equal distributive property on the left side. Since there's a variable, this becomes 64 plus 8x. And now you do 7 times 24. I'm going to put the calculator out. Make sure I get this correct. 7 times 24 equals 168. And then here, and you can solve this like a regular equation. There aren't variables on both sides, so you don't have to worry about keeping the constant on the right and the variable on the left. Here, I am just going to, or I can do it. I want to put the constants on the left side, so I'm going to minus 1. Well, I'm going to put the constants on the right side. So I'm going to go into minus 168 so we can be consistent. So I get 0 constants on the left side, and that equals 64 minus 168, which is negative 104, plus 8x. And then we're going to get our variables on the left side. So if I cross over my blue line, then I have to change the sign. So negative 8x. So negative 8x equals negative 104. Divide by negative 8. Divide by negative 8. So we're done with switching stuff around. So x equals 104 divide by negative 8 equals 13. So we got x equals 13 in this case. And you can go back and check it. Go back and check it. So if you put 13 here, you should be able to do the math on the left side and get 168, and then 8 plus 13 times 8 should also equal 168. So these two sides should equal each other if you are correct. So go ahead and complete the rest of these problems, and I will see you guys in class. Bye.